So, chapter 10 is on conics. So we are going to start with parabolas today. Moving on, here we go. So a conic section is formed. So this is how I think of it. You've got a stationary line, and then you have one that's revolving around it. So I think of when somebody's twirling the baton. You know when they're twirling fire, you can almost see the shape it's forming. Kind of looks like this. She's twirling around. So you get these two cones when they're put together like that. It's called a nape. All right. So if you've got a plane that's cutting the nape parallel to the generating line, it creates a parabola. If you have a plane that cuts one of the napes all the way across, it forms either an ellipse or a circle. So if it cuts it straight, obviously it's going to be a circle. But if it cuts it tilted, it's going to be elongated. So it's going to be an ellipse. And then if it cuts both napes, you get hyperbola. Right? So we are going to focus today on parabolas. So you've known parabolas for a few years. You know there's a vertex, all that fun stuff. How do you know if it's opening up? The A is positive, right? If you're opening down, it is negative, right? So today we're going to go beyond that. We're going to talk about the focal point and the directrix, which is what's actually guiding the shape and width of the parabola. And we're also going to talk about parabolas that maybe aren't functions. Okay, so focal point is always inside the curve. The directrix is the same distance away from the vertex as the focal point. So this distance here is the same as this distance here. So from the vertex to the focal point is the same distance as the vertex to the directrix. The vertex is the middle point between those two things. So the directrix is always a line, either x equals or y equals. No matter where you are on this parabola, I can pick any point. If I draw a line from here down to my directrix, it's going to be the same distance as that to my focal point. They're equidistant. Okay? So no matter where you are on the parabola, the distance from the point to the focal point is the same as the distance from the point to the directrix. But very, very important to understand that the vertex is the same distance from the focal point to the directrix. Okay? Now, this distance is the p value. Very important. The distance from the vertex to the focal point or the vertex to the directrix, same distance, is p. There is something called the focal distance. That is the width of the parabola, or the focal width, I'm sorry. The width of the parabola at the focal point is called the focal width. That distance is 4p. So I can take 4 of these little and put them in there. Okay. Easy enough? So the next slide just shows you the 4 different variations that we're going to talk about. You do not need to write all 4 of them down to understand when one is one and then the other is the other. All right? So this is the one we just talked about. The x is squared. Okay? This one also, the x is squared, but it's negative. It's going down. If the y is squared in the equation, we're going to get to the equations on the next slide. If the y is squared, it's opening either right or left. This is the positive opening, so that would be a positive A. If it's opening this way, it's a negative A, just like positive, negative. Okay? But it still has the same directrix, focal point, all that fun stuff. So let's look at the equations. So I would write these down, most definitely. Notice the x is squared in the first equation, so I know I have a vertical opening up or down parabola. One of these, which is what we're used to. But we're going to write it in this form. So the squared parenthesis is going to go on the left. The variable that's not squared is going to go on the right. Notice that the variables are both in parentheses now, so when you're finding your vertex, it's opposite out of both parentheses. So the vertex is always HK, even though they show minus H and minus K in the formulas. This big A here is equal to 4 times that p-value. So that's very, very important to know. The big A is equal to 4 times the p-value. A horizontal parabola has a y squared, so it's either opening to the right or to the left. And again, this would be a positive and a negative A value. Remember, when you're doing your vertex, the H is the X part of the vertex. It has to come from the X parenthesis. The K is the Y part of the vertex. It has to come from the Y part of the parenthesis. So, or the Y parentheses. It's very easy to get these flipped. Okay, this is your K. All right. So, let's look at a problem, see if we can do it. What is the vertex? Opposite 5, negative 1. Everyone with me? Not hard. Is this parabola opening up, down, right, or left? Opening down. It's opening down. The x is squared, so we know it's vertical. It's a negative, so it's going to be opening down. So I'm just going to kind of write what I know about here. You also need to figure out how big the p-value is. So remember, 4p equals what? Negative 8. And I really don't know. I don't really care if you figure out the p is positive or negative. It's a distance. So your p distance is 2. Okay? So let's graph what we know. 1, 2, 3, 4, 5, down 1. We know it's opening, we said down. So where's my focal point, above or below this vertex? If I'm opening down, where would the focal point be? Below. So we're going to move down 2, and that's my focal point. My p is negative, so you're moving down to get to the focal point. Okay, if you want to think of the negative as useful information. The directrix, again, I'm at my vertex. I'm going to go up 2 to find my directrix line. So that p-value you got to find, because you're going to go up, down, or right, left, depending on the parabola. So if I wanted to find my focal as a point, I'm moving up and down, so I'm moving the y value. So my x is still 5. I was at negative 1. I went down 2, so I'm at negative 3. The directrix is a y thing also. And it's y equals 1. So if it's a vertical parabola like we have, all the y's are going to change with those things. And what is my focal width? What do we say focal width was? Did we write that? It's just 8, right? It's 4 times p. Do not write negative, though, because it's a width, it's a distance, so it's always going to be positive. It's the absolute value of that capital A, or that 4p. Now, to graph this, I've got my vertex, I've got my focal point, I've got my directrix. My focal width is 8, which means from the focal point, I'm going to go 1, 2, 3, 4 to the right, 4 to the left. The entire distance. So think of the focal width as a diameter, and the distance here is a radius. It's going to be half that. So you're done. That makes sense? You able to find all those little pieces? try another one. You guys see what all you can find. I just want to make sure you're starting it right. Do you get 4, -1 as your vertex? Remember, x part comes from the x parenthesis, the y part comes from the y parenthesis. Okay, that's real easy to switch around. And I got p is 2.5? Yes. Even without my calculator. It's pretty amazing. Are we opening up, down, right, or left? Up, right. It's a sideways parabola because the y is squared. Oh, y is squared. Right. So we're opening to the right. So if I'm at 4, -1, we're going to change all the x's now. So the focal point, I'm going to take 2.5 and add it to the 4. Right? My directrix is behind my vertex, to the left of my vertex. 1, 2.5. That puts me at x equals 1.5. Make sense? So the first thing I always do is, which way am I going? Up, down, right, or left? Get that in your head first. Focal width is 10. So when I go to graph, my focal point, you're going to go up and down how many? Yep. You need a total of 10. Max? The directrix is 2.5 units from the vertex the other direction. Okay, 2.5 forward, 2.5 back. That p-value, very important. All right. Okay, so next couple slides, we are going to write the equations given some clues. It's almost like a escape room type here. We're looking for clues. It's a puzzle. All right, find an equation in standard form for the parabola whose directrix is the line x equals 2. So here's my directrix. That tells me one thing. Does it open, is it an up and down or left to right? It's got to be left to right, yeah? So I know already that my y is going to be squared. Just from knowing the directrix is going up and down. The focal point is -4, 0. That's my focal point. This is my directrix. What's in between them? What's right in between the focal point and the directrix? The vertex, right? So split the difference here. It's going to have to be here, right? The distance between these two is 6. So it's 3 units. So that's my vertex. So my vertex is -1, 0. Which way am I opening? Right or left? Look at the dots I've got graphed there. Does it open towards the focal point, yeah? So we're opening this direction. So is it a positive or negative? Negative. So see all the little clues? If you sketch it, you're going to start seeing it. And then we got to figure out that p-value. What's the p-value? It belongs at 3. So this is going to be 4 times p is 12, and it's negative because it's going to the left. And then you could write this a little bit better. Y squared equals -12 times x plus 1. Okay? Does that make sense? All little pieces. These things go in a row. Directrix, vertex, focal point. Okay, try another one. This one's really easy. It's opening downward, so is the x squared or is the y squared? X is squared. So that's where I would start. It's opening down, so I know it's a negative. Oh, they give me the vertex. I can put that in, right? And we have a focal width of 16. Do I divide the focal width by 4? To find the p-value, I would. But this is just, yeah, this is the focal width. And that's it. So remember, that focal width equals 4 times p. So if you want the equation, you want that focal width in there.
Did you know the focal width was?
Because we are opening downward. So the focal width is 16, but the negative because it's down. Okay? All right, so I got the standard form of a parabola whose vertex is -1, -4, and opens to the right, and directrix is -3. So there's nothing wrong at all with graphing and kind of sketching what you know. So that's my vertex. My directrix is here. So that should tell you which way am I opening, up, down, right, or left. Right, correct? Okay. So we're opening to the right, which means my y is squared, and I'm positive. My vertex was given to me, so put your vertex in, and then figure out what your little capital A or your 4 times p would be. So you got to figure out what your p is. P is 2. So p here is 2. So in the equation it's going to be 8. What goes here? Plus 4 and plus 1. One thing at a time. Figure out the direction of the opening, whether x squared or y squared.
If we were to open one, you make the 8 negative.
Yes, sir. Mm-hmm. And that moves the directrix on the other side. Okay, so you can sketch to get your information. You can also look at it and say, well, I see an x thing here and I see an x thing there. The distance there is 2, so p equals 2. Because I'm going from a directrix to a vertex. Okay? We good? Last one, and then we're going to do completing the square. Does anyone have questions on that? I didn't have it recording. Okay? So we know it's opening to the right because it's opening towards the focal point. Then you're going to put in your vertex. Your p distance is 5, so 4 times 5 is 20. Moving on. All right, we are going to rewrite these in standard form. So remember before, I don't know what chapter it was, but we did completing the square, and we said it's going to come back up. So you have to know how to do it. This is when it comes back up. So I am going to put everything that is a square thing on the left. That variable's on the left, and then the other variables come on the right. So y is squared. So I'm going to move my -3y squared to the other side. I'm going to move my 24y to the other side. I'm going to move my x to the right. So we're going to start with positive 3y squared minus 24y on the left, negative x minus 2 on the right. Did I lose anybody there? All we're doing is moving things from right to left and changing their signs. Okay, so whatever the variable is that's squared, all that stuff goes on the left. And now we're ready to go. So before we complete the squared guy has to be by himself. So we're going to take out this 3. Remember, that's not the greatest common factor. You're just factoring out that coefficient. And then we have to figure out what are we going to add. So remember, it's half of this new b value squared. So half of 8 is 4, squared is 16. And on the other side, what are we going to add? Be careful. 48, because we're multiplying this whole set by 3. Everyone with me? All right, so we have 3 times y minus 4 squared. Remember how we had to factor that earlier. Equals negative x plus 46. Now, in standard form, both variables are in parentheses. So I'm going to factor out anything that's with my x. I have a negative 1 with my x. It needs factored out. We're looking pretty good. What's wrong? We got one more step to make it in standard form. The squared bracket should be by itself. So what do we have to do with the 3? Divide it. So you're just going to divide it in the front. So we're creating that a value, that 4 times p value. And you're done. And then what is my vertex there?
4.
I got that.
46, 4.
46, 4. All right. That's a real schemy parabola. All right, here we go. Let's try this guy. You guys go ahead and work your magic. Okay, first step is to move the x and the 1 to the right side. So we factored out the 3. Then we took half of the new middle, squared it. Remember, when you add to the right side, you've got to multiply anything you factored out. Factor out the x's coefficient and then divide. Can we do that? We good? All right.